In this presentation, we're going to go through some of the basics of geographic information systems, commonly referred to as GIS. Now, what a GIS does, or a geographic information system, is it does three main things. There's three main components. And throughout this presentation, we'll be discussing each one of these. The first is data storage. It's a place where we can take spatial data and we can organize it, we can put it together, catalog it, and make some sense of it. The other thing that we do is we can create new data. We can use pre-existing data sets, combine them, or extract information from them. We can also just click on the screen and make new information. And of course, we can make maps. That's always great to be able to show off the information that we have available to us. The third thing that we can do is what's called spatial data analysis. And that's really asking questions about locations. So let's get into it. What is spatial data? Well, spatial data, if we think about the word spatial, that's related to locations. And so we're thinking about data that is tied to a location. Now, most commonly we think of maps as spatial data. We might think of addresses. If you think about the information that comes across in your address, it's very specific about a house number and a street name and a postal code. General names sometimes will work as well. For example, main campus, CRC, might bring to mind a location. Disneyland brings to mind a location. Hey, San Francisco, as a name itself, can also, for example, bring about that. What we do want to take a look at, though, however, in this presentation is data layers. And if you do have the opportunity to take my GIS class, and we'll start to talk a lot more about data layers and how those relate to maps, a map is going to be a combination of many different data layers along with some mapping elements. Let's talk a little bit about those data layers. In a GIS, data is stored in one of two different ways. It can be stored as a vector data, and that vector data consists of points, lines, and areas, or it can be stored as raster data. Raster data is going to be a grid of information. For example, an image is going to be raster type data. All right, so if you think about a digital image, if you zoom in close enough to that, you can actually start to see pixels or tiny little boxes, and each box is going to have a specific value in it. So raster data is going to be data stored as values in a grid system. Imagery, sometimes coded values, will also be found in those. Wait, what is it that he says? He's Vector, right? He's the superhero or the supervillain. Then vector has direction and magnitude. Okay, that's not exactly the vector that we're talking about, although maybe. All right, let's talk a little bit about these two different data types. I want to get a little bit broader pen here. So the first one that we want to talk about is vector data. Now, vector data is just data that is stored as coordinates. Right? And we're going to talk a little bit about this as we move forward, but it all has to do with the coordinate values. Right? And when we're looking at vector data, we're going to have points, and we will have lines. We're going to refer to these as either lines, or sometimes we'll refer to them as polylines, and areas. And these guys we'll refer to as polygons. Okay, now this poly little prefix that we're putting on both of these, it just means multiple, right? And so if you have a hexagon or a pentagon or anything else like that, that's going to be an area with a number of shapes. Polygon just means it has a lot of edges to it. Okay, a line, we'll talk about the difference between a line and a polyline in just a moment, but a polyline is going to be a segment, a line that has multiple line segments included in it. So let's go to the very root of all of this. Let's think about the points, right? In order to do this, we're going to need to have some type of coordinate system. And we're going to establish a location. Now we have our X and our Y values for that. Now we're going to need to establish a location, and that is going to have a coordinate value. It's going to have an X and a y value. Now, it might also have elevation data, and in that case, it would also have a z value to show how high it is off the surface. But for most of our data, we're just going to have xy data, right? And that's going to be individual point. And so we might have a point there and a point there, and that's going to have an x and a y value associated with it. And there might be another point that is established right here, and this has an x and a y value associated with it. And that's going to be how those points are stored. Now, we're not necessarily going to be going in and being able to look in the attribute table or anything like that to see what the coordinates are, but in the geographic side of our GIS, it is going to be stored as points. Lines are just going to be the connection between points. So let's say that we have a line right here, or a point right here, and this is going to have an xy value associated with it. And there's going to be another one right here that has an xy value, and those 2 points are connected. And where 2 points are connected, this is a line. Right, so we have our points, and our lines are established based on that same geometry of the coordinates of our individual points. Sometimes we refer to them as points. Sometimes we refer to them, when we're talking about the creation here, as a vector. Oh, he's back. Okay, so our vector. Now, if we were to have multiple points, and they were to all connect with each other, then what we would run into is a line and a line and a line and a line and another line, and we refer to this as a polyline. Multiple line segments all kind of put together. The other thing that we can do is we can have a number of different points that are all there. Those points are connected with line segments, and so you might think, oh, it's a polyline again, except these guys can all close in on each other, right? And when we have an area that has multiple line segments, again, xy, all based on that coordinate value, these guys are going to be a polygon. Right, so vector is going to be one way that we're able to store our spatial data. The other thing that we're going to find for a lot of our spatial data is going to be raster data. And in raster data, the information is stored as a grid of information. Okay, and so I'm going to make a very simple grid. We're going to have our 3 by 3 grid. Right, and each one of these individual boxes, or each one of these little areas that we have right here, they're going to have 2 names. They can be called a pixel, or they can be a cell. Okay, now each one of these pixels is going to have a specific value, and that all depends on the way that the information is being stored, what is being stored in there. One very common way that raster data is used, that raster data is stored, that's going to be in the use of imagery. So if we have an airplane or a satellite fly over, imagery is going to be one of our common ways of doing that. And when they're doing that, if we think about the way that data is stored in a computer, we're going to want that to be 1 byte of information. That's going to have each pixel will have a value between 0 all the way up to 255. And the reason for these funky numbers is it has to do with 8 bits makes a byte, and 1 byte of information, 8 individual zeros or ones would come up with a range between 0 and 255. Much more detailed than what we actually need to get to, but an image can have a value between 0 and 255. And that's going to be either a very high value or a very low value, right? So if we're thinking about a black and white photo, there's going to be some areas that are very light or very dark. Now, the other thing that we can do within this GIS, and it's really almost done automatically, is that we can create 3 different layers, 3 different raster data sets. So we're going to have one raster data set there, and then we're going to have another one that is associated with it, and another one that's at that same location. And these guys are each going to have different values associated with them. This is going to be for our color imagery, okay? And I'm looking for all the right colors, but we're going to have one layer for red. Oh, that looks a little, not quite right. Red, RGB, blue, and green. Okay, again, each of these are going to be individual little cells or pixels. And each one of these pixels for red is going to have a value between 0 and 255. And for green, it will have a value 0 to 255. And for blue, it will have a value of 0 to 255. We call this a composite. We call this a pen that isn't working. We call this a composite image. And that way we get our color imagery, right? So if you're creating colors digitally, you might use CMYK if you're in the printing industry, but RGB is going to be another very common way of doing that. Now, again, these are raster data. They don't necessarily have coordinates, but they do have a place in the world, right? So there will be a point that will be tied to a location. There will be a rotation that this guy is set at. So they all do have coordinate values or coordinate systems assigned to them. It's just not storing the data as individual little individual coordinate points.